Hey there, it's Mr. Canner. And if you're wondering what you just saw, that was Max's goal from last week in Champions League. That was a great goal, but let's not get into that. Today we're going to talk about calculus. Now, why are you wondering why you saw that goal? Well, what I want to do is change it a little bit. So here we have Max's goal again. And what we want to do is, there we have it in slow motion. So this sort of parabola it makes, they tell us that the equation of the trajectory of the ball made is this: fx is equal to square root of x minus 2. So we have that. Now let's just imagine that in the video, I don't know, a bird crossed by, and they tell us that the bird touched the ball at the point 3. So let's just imagine point 3 for us is going to be when the ball is over the defenders. More exactly, right about here. Okay, I don't know if you can see it. There it is. Here's the ball. Okay, so let's just imagine that's our point 3. So they tell us that the equation of the ball, the trajectory made, is square root of x minus 2. But they're asking us to find the equation of the bird, of the bird. So how is this related to calculus? Well, we have to first of all find the derivative of the equation of the ball, and then well let's get that first. Alright, so we're finished. So here we have the equation. What we're gonna do first is write it in another form, which is x minus 2 to the 1/2, which is the same as square root. Then what we do is we take the 1/2, you see it, and we multiply it in the front. So we have 1/2 of x minus 2 to the minus 1/2. Why the minus 1/2? Because remember we have to subtract 1 from the exponent, okay? So now that we have that, we have to multiply it by the derivative of the inner function, which is x minus 2, but the derivative of x minus 2 is 1, so we don't have to put anything. Then what we have to do is write it again, and we would leave with this: 1 over 2 times the square root of x minus 2. That would be our derivative of the function of the ball. Okay, so now that we have our derivative, which is 1 over 2 times the square root of x minus 2, what we're going to do is input our number, which was 3. Remember that we said that our 3 is going to be where the ball is on top of the defenders, right here. Okay, so that's going to be our point. So what we're going to do is input that 3, that x equals to 3, into the x of the derivative. So what we're going to have is this. Okay, so here we have our derivative, and here we're going to input our 3, you see it? Our 3 minus 2 times 2 over dividing 1. So we do the procedure, is square root of 1 times 2, and then we have 1/2. Now this 1/2, what does this 1/2 mean? It means the slope of the equation. It would be 0.5. This would be the slope of the equation of the bird. Okay, so now that we got our slope, remember this little formula, point slope form. This is to get an equation, okay, remember? So we got our slope, and we got our x1, which is 3, the one they gave us, remember, over the defenders. But we're missing our our y1. So what we're gonna do is input the 3 in our original formula, which was this. Remember, the x minus 2. So we do this. Okay, So fx equals to 3 minus 2, that, the square root, we're going to get square root of 1. Okay, so it's going to be 1. And our point is going to be x1 equals to 3 and y1 equals to 1. So what we do from here is just substitute. We get y minus 1 is equal to 0.5, which is the slope, times x minus 3. So we're going to get y equals to 0.5 of x minus 1.5 plus 1. So we pass the 1 adding, okay? And we get as a final answer this. Y equals to 0.5x minus 0.5. So this is how you get the tangent line, the equation of a tangent line in a certain point of a given equation. Here we took the example of Mex's goal, but you can take any example you want. Thank you.